Hello, welcome. I'm going to talk about how we get the benefit of the async. And I want to talk about two examples today about circuit breaker in a REST architecture and an orchestrated saga. First, I would like to present myself. I have 13 years of experience. I am tech consultant in ThoughtWorks. I had worked in different roles like tech lead, developer. I was also advisor of some technical initiatives. I had worked in different contexts also, like cloud native architectures is one of the topics I enjoy, as event-driven architectures also. But I had worked also with security and API management. But what I like most about technology, it's actually solving business problems, like this ability to connect what is the business need with the solution we are proposing. Today, as I commented, what I will do is share with you today two stories of architectures I had worked on in different teams. How we get benefit with an async communication in them, and some learnings. The first story I want to share is this. We need to implement a solution to incrementally migrate some data of the customer from an old system that was a monolith to a new system that I'm going to explain later more details about. We needed also the user input because we require the explicit consent from the user for the migration, and we require also to update some information that was requested to the user. More context about the ecosystem, the new system where we will migrate the information. It was composed of multiple microservices. For example, in this case, I have a user resource, a customer resource, and a loyalty account resource, as I'm showing here, and the APIs exposed. This was great, right? Because it allows us to minimize the design coupling in the solution. Changes on each of these bounded contexts evolve independently. And also there are independent teams managing the life cycles of the APIs, which is great. What we did with the problem we need to solve is first we understand what was the problem space, and then we incrementally define and refine our solution as a transaction because we need to migrate all the information. How this transaction looks more or less was something like this. We have different calls to these different APIs that belongs to these different microservices that were independent, and we need to consider what as a whole means successfully and what are the different error scenarios that requires a rollback. That was basically the way we design our solution. Then what we began to do as the implementation is we create an API composer while we was refining how this transaction looked like. Our intention was to ensure that information was migrated to each bounded context, as I said, to each of the resources I showed a couple of slides ago. We wanted to migrate all this customer information that belonged to a system, like the old system was a monolith that has a central database, and now we need to move to this new system that was based on microservices. The API composer, conceptually, it's another microservice. It's exposed some APIs. But what it does, it's basically compose the request and the response based on the different elements that compose, in this case, this migration or this query that I am creating. Additionally, we have an API gateway as a way to manage the security of this API's composer. So I will have a first call, I will manage that response, I will have a second call, and I will have, in our example, a tier call. And basically, that was the responsibility of this API composer. But if you think about, we ended up creating another type of coupling. Even though this solution was designed with like thinking about making all of these elements not couple, we ended up having the runtime coupling. What it meant to us is that the availability we have in our APIs composer then depends on the availability we have in all these microservices we were calling. It meant we need to handle retries, we need to handle timeouts, and we need to handle fallback responses in case any of these APIs were not available. How our flow initially looked like that I showed at the beginning was something like this. But we ended up realizing that our rollback was bigger than we thought at the beginning. We needed to have compensation APIs that allow us to undo the changes we have in case of failures. And what was more complicated for us to solve was how to compensate if the compensation fails. Then we thought about the circuit breaker, right? This circuit breaker, it's a pattern that think about retrying an operation if it's likely to fail. Let's think about this. We have our circuit closed while we have success. Then we retry. And if we face a failure, what we do is when we accept the retries we have configured, then the circuit is open. Then we have a fallback response because the operation is likely to fail, so we don't try again. But then we move to a half open. What it means is the same time we are aware if the system is up again, if this API that I depend on is up again, and then I restart the circuit to a closed status. Following the same principle of the circuit breaker, what we did in our architecture was simply something like probably you have in your architectures also. We defined threshold. What was our tolerance in case of failure? So for example, let's have a first call. This first call takes about 1 second, okay? We are okay with that. Then let's think about this second call. Probably it will be less, it will be milliseconds, but just to give you an example. Okay, let's assume 2 seconds is fine. But then this third call is the one that failed. So the total time that it's taking the end user to actually get an answer after this user said, you know what, I'm okay with migrating my data, I'm okay with updating my data, but I'm not giving an answer. And it's getting bigger, 22 seconds. So the next thing we do was define a fallback process in the case of failure of this third call. For us, because this was an HTTP REST-oriented architecture, we follow the HTTP standards. And for us, a 424, what was meant this failed dependency? Together, this with a good error code was able to translate at the end user, at the customer, you know what, your information is still processing. When it is finished, we will let you know. Meantime, you can continue checking our offers. For us, it means that the system was most of the time available and working, but in case it was not working, we try to bring the best experience to the user. And also for us, it means to solve our transaction. The last part of it was, okay, now that it failed, let's complete it async. So instead of having this sync call, like the original REST call, we have a messaging mechanism that allows us to make the call async. That way, we can notify later to the end user, you know what? That processing that was pending was finished. Coming back to our flow, what this circuit breaker allows us was to determine what is a non-retriable failure, in which case we will need to compensate, and what was a retriable failure. Because the API, for example, did not respond on time and we get that timeout. Configuring the number of retries, as I commented before, and configuring the fallback response, then we were able to try again, to try this in this async way and return a partial success response. With this partial success response, we were able to continue the flow. And what was more important for us also was these mechanisms allow us also to handle these scenarios of what happens if a compensation action didn't work. Some learnings from this story. The understanding of the business logic for us was the key part. We needed to understand what was from the business a success complete migration, a partial successful migration, and what information could be migrated later. Also consider that we were capturing some data from the user at that point. So we needed to determine all of these different statuses. A transaction in a microservices architecture, as you saw, if we compare to a monolith, as I commented, with a central database, implies more things. In our case, it implied this coupling in runtime that we need to consider in our design. We have mechanisms to build resilient solutions. In our case, we follow the principle of this pattern of circuit breaker, and it allows us to handle these edge scenarios and to handle unavailability in our overall architecture. The async mechanism for us also implies some privacy concerns, because we need to think about, like, also now that this communication is not synchronous, there is some information that it could be personally identifiable information that will end up in a message, in a topic. What did it imply? And that were one of the reasons we designed to have only the async mechanism in some of the elements of this overall transaction, but not in all of them. A good error handling is key. For us, it was the way we were able to actually say, this is a retriable operation or not. Should we try this with a messaging alternative path or not? In our trade-off analysis, we made a decision. We prefer retrying over compensating to reduce the risk that the compensation will fail. And we design our solution and we implement our retry mechanism and our circuit breaker and a way to follow this decision. And finally, what I want to bring with this example is that it is possible to have hybrid solutions. In our case, we have already a monolith that was developed in the past. We have already a microservices architecture that was sync, that was based on a REST sync communication, and we were not able to change it. So what we did was think about how to solve the need we have and how to take benefit of the async. And it didn't imply redo the complete architecture. It was just adding this component and have a good error handling, have a good also manage of the different responses. Now I would like to talk about the second story. The first story, as you saw, it was a REST architecture, and I commented to you, I promised I will talk about how we use circuit breaker. The second story, what we need to do was generate and implement the solution of notifying the customer, but we need two criteria to be covered. One, to know the preference and use the preference as a guide of which mechanism to send the notification, and also have the different mechanisms like by email or by SMS or other mechanisms. Before talking about how we solve, I would like to talk about what is a saga and why we use it. As I commented in the API composer, right? We decided to define this concept of transaction because for us, it was part of the domain problem, right? We need to migrate all the information and we need that the information has some relationship, right? If I have a user identification and a customer identification, I need that both of them were connected in this distributed architecture. In this case, the saga, it's basically this idea of generating a transaction based on the local transactions that happens in each microservice. Conceptually, how a saga looks like, it's you begin with the compensable transactions. These are transactions similar to the previous example I showed that you need to undo, basically. So you need these compensatory actions. Then you have a pivot transaction that is basically after I have these compensated transactions, this is like a conditional, right? If this transaction is successful, then I will move to the next stage. And the last stage are the retriable transactions. That it means now that I had passed all the compensable transactions, my pivot transactions, if this fails, I will just continue until it is successful because the conditions were like covered in the previous steps. Saga is a concept that came from how we did in the past DB level atomic transaction and how we need to keep this data consistency now in a distributed architecture that involves multiple microservices. We had two options of Saga that it's also important for you to know. The orchestration on one hand and the choreography. The main difference between these two is that in orchestration, the decision-making is centralized. And in the choreography, it is distributed, which sounds very simple conceptually. It means that the coordination logic belongs to a central element that is the orchestrator. And in the choreography, the coordination logic is spread in all the participants. It means that in the case of an orchestration, I have a clear responsible of who will need to call the compensations in case of failure. But in a choreography, each of the microservices I have should be responsible of triggering these compensation actions. How we implemented our orchestrator. Okay, so coming back to the overall idea, we want to send a notification to a client based on their preferences. Think about an orchestrator as a persistent object that implements a state machine. And as I commented, that is responsible of invoking each participant. So this transition of status belongs to the orchestrator. We decide to use an orchestrator as I am showing here because that way we have this overall logic centralized. If you think about the Saga and how different status flow, like while we are moving in the different calls, we began getting the customer preference. And for us, conceptually, it meant an enriched state. If we were not able to get that information, then we consider a by default state. The next step for us was a created state that means this persistence of this notification object that represents that status. After it is created, we will use a mechanism, a messaging mechanism, and it will be queued. And it will be processed eventually. But what we can do at this point is return the notification ID already. Then, after this is processed by the mechanism that is the preference of the user, or in the case it is the default mechanism, I will have the later states. It will be a send. That for us, it means that in our solution, we were able to communicate with the provider of the service, and this provider returned us a successful response. But then the provider was able also to notify our solution in the case it was delivered to the end user, or in the case it was failed in the delivery. Some learnings from this story, which is a little different of the first one I talked. Again, we need to do a trade-off analysis, and we chose an orchestrator. We were able to have developed the same solution with a choreography, but we considered it was inherently more complex, and we wanted to reduce the risk of failure in this complete distributed paradigm of managing the compensation. Think about like if you choose a choreography, then this responsibility will be spread in all of the participants. For us, the decision of choosing an orchestrator helps us also to test all the different flows we have in this logic for the notification. Observability, it's key. And it's key not only for this example, it was key also in the previous example, it's key in each solution, I think. But in a Saga, I think it's very relevant because we need a good way to track how different status were changing. I mean, you have the orchestrator that is persisting those status, but also for us, it was very helpful to be able to see in all our solution how these different costs, these different compensation actions, for example, were invoked. And what was very important is because you have different microservices, to be sure that all the trace ID are passed in all of this flow as a way to help you to understand what is happening in the system. We decided intentionally to separate the sending mechanisms as different microservices. We did that, again, intentionally by making these decisions because we wanted to handle like auto-scaling in each of these microservices depending on the volume of the notifications. For example, if we have more notifications that were by email, then these microservices will scale more than with other mechanisms. And similarly to the previous example, my message is the same. The understanding of the business logic is the key. For us, this was a good example of how a solution could solve a problem that by nature was async, when the expectation of the user was to be notified eventually. So it was a good candidate for providing that user experience. Thank you very much. I hope you like these two examples. I wanted to make it really simple and bring in, there's a lot to share about these architectures I have worked on, but I wanted to especially focus on how to get the benefit from the async.